Hello everyone, welcome to the Ultimate API Challenge, a place where we work, grow and learn together with different APIs as well as with a variety of different changing tech in order to hopefully by the end create a project that can be put on your web development portfolio. Your knowledge level doesn't play the biggest role, however your willingness to learn and to challenge yourself does. To learn more about the project and previous challenges that were already covered, check out the link in the description below. So in this video we're going to be building the Wikipedia API. We're going to be using Axios as a way to communicate with our API, as well as async await, and we're gonna use try and catch block, and of course everything including HTML, CSS and ES6 JavaScript. So if you're excited about this challenge, let's get started. We all know Wikipedia, and I'm sure we all have used it more than at least once. I know I did, but did you also know that they have their own public API? It does make sense that they have it, but it didn't occur to me to check that they have it. But the API documentation is so complex, so I thought it can be a good chance to see how complex the documentation can be and how we can work our way through it. It took a while to figure it out, but we're here. So let's start. Let's check what we have. Refresh the page. Straight away we have a focus input field. If that's the only functionality that we're going to have on the website, then why not save the user this one click or press on the top and just lead them straight to the point. So I want to know what's an API. Search for it. I disabled the form in the meanwhile, so we're not going to have multiple submissions. And there we go. We have our list limited to 20 results. You'll see how to do that and you can change that. And these ones have some tiny hover effects. And let's maybe select one and click on it. Clicking on it is going to lead us to the actual article in Wikipedia. Now that we know what we need to do, let's check our steps. First, extract all selectors, create helper functions. So if you've done previous challenges, you would know that we usually find ourselves typing many times the selector and then needing to reuse it. So in order to avoid this, and I know that eventually we are going to be reusing them, let's just extract them straight away, store them in their variables, and then it's easier to work with them. We know that we will for sure need our button, and we can call it submit button. Const submit button. We're using vanilla JavaScript. Document, query selector, open parentheses. We can always inspect, right click on the mouse or left, depending on your mouse configuration, inspect. Then we choose this option, you hover on it, and we get ID submit. And that's what we're gonna pass here. Hashtag submit. The next element is our input field, const input, document, query selector. We're going to do all of them with query selectors for consistency, ID input. We're going to have error handling, and I have included in the index little error paragraph, const error span, query selector, string, hashtag, error. And the last one would be this container that we have here that shows our result, which is results. Const result container, same document, query selector, results. All right. Create helper functions. So as I mentioned, once you submit the form, this button goes disabled as well as this input field. If I'm going to submit now, you're going to see that. You saw it for a slight millisecond there. Let's try again. Pay attention to the cursor. It's going to change. You see, this is going to be our disable UI function that we're going to call once we have a request going on. Const disable UI error function, because we're doing ES6 for fun. We will need our input dot disabled to be true and our submit button disabled to be true. If we have disable UI, we need to have it enable UI. So again, const enable UI error function. You can copy this, paste it here, but change the values to false. Another thing that you could do, you see that those functions are quite repetitive. You could write const change UI state error function and write input dot disabled equals something, submit button dot disabled equals something, and this something is going to change depending on where you call the function. So for example, if you call the function straight once you make a request, you want the UI to be disabled, so you're going to pass here a flag is disabled, and once your request has finished, then maybe you want to enable the UI and you're going to pass that the is disabled is false. So you could write it this way, is disabled, and in here is disabled, and you could save yourself these lines of code. Totally up to you, and as always in coding you have multiple options, so just pick one. Next, we're gonna have such thing as clearing the previous results. Let's say I'm going to search for Apple, and when I search for Apple, I don't want this results to be shown. I want this to be cleared and show me only the Apple results. So we can achieve that by creating const clear previous results error function use the results container, set the inner HTML of it to be equal to an empty string, as well as our error span inner HTML to be equal to an empty string, because we don't know if what we searched for gave us an error or showed us the actual results. To be on the safe side, we can clean both of them in one go. And another function that I like to use, and I have used it in previous challenges, is a helper function to check if our input field is empty before submitted the request. Const is input empty, going to pass to it the input field, and we're going to say if no input, or that's an important one, input equals an empty string, and that can happen if you type in something and then you remove it. It's not clearing the whole input field, but it keeps the string empty. So we need to double check for that case as well. So if it is, then we want to return true. Else, in any other scenario, we're going to return false. Last but not least, const show error, error function. We're going to pass it the error or the message, and we're going to output it. Error span dot inner HTML equals error. I think we're done with step 1, extract all selectors, create helper functions. Done. Let's give it a save. It's gonna add now semicolons. Beautiful. Now that we have our something, it's time to visit the API's documentation. And they have many different links. Let's start with one. The starter files. Open link in a new tab, and here we are. Oh, it's a lot. If you have the time and the desire to go through the many things that can happen here, it's a pretty big API, which was sort of what we expected from Wikipedia, right? You can select different languages that you want or different endpoints that you wish to call, but we're gonna go with this one, with the English Wikipedia API. Click on that one, and yeah, here we are. I don't know about you, but just seeing this amount of text is already repelling to me. So the way Wikipedia works, you can actually see here, it basically tells us how to build the whole URL to get the results that we want. So in order to do that, I'll save you the whole information that is happening here, but by all means, feel free to go and dig into it yourself. I'm going to tell you that in our parameters action, what we're going to be searching for is query. Fetch data from and about media wiki. Go and click on it. This leads us to a whole new page again. And if you scroll to the very bottom, you can see that we have examples here. You see they have the API.php question mark. That's what we clicked on in the Wikipedia article that we came from. This is what we're going to be building basically. Let's first extract our endpoint, just so we're not going to lose it. Const endpoint equals, copy it from here, paste it, create an object called params. And as we clicked on query, you see here also in the examples they have action equals query. So that's what we're going to write. We're going to write action, and then in a string, we're going to define that it's query. Later on, Axios is going to help us to construct the URL that we need. We just need to define in the params object all the params basically that we want to have in our URL. We know that we have action, and if we go to the main documentation, open that up again. So you see here as well, we have parameters action. We go here, that's where we found our query. Then another thing that we have is format, and we want our format to be JSON. Define it, format, JSON. And another important thing, if you have done previous challenges, you know that sometimes we have this coarse issue that in order not to have it, we need to set origin and to specify its value to be an asterisk. In our case, this is something that suits us because it's going to set a header access control allow origin, which is what we want as we're going to be making non-authenticated requests. Origin asterisk. Save it. Cool. So we have our base. So let's get back to our other page that was open. We have a prop, and then we need extracts. Returns plain text or limited HTML extracts for the given pages. That's what we want. Prop is extracts. Then we can also go one level deeper and see what these extracts offer us. For example, we have xchars, how many characters to return. That's something that interests us because here, as you see, it doesn't return us the whole article. We just want some amount of information to give a user a hint if that's what they're searching for. And we can do that with this xchars, which is the type is integer and the value must be between 1 and 1200. The way you define it, you just continue specifying everything on the params. So xchars or xcars, because it's characters. In our case, it's going to be 250. Then xintro, return only content before the first section. Xintro is true. And another one, explain text, return extracts as plain text instead of limited HTML. So you could as well get the HTML that Wikipedia offers, but I find that with our little square, it kind of messes up with the styling, and it also includes for some reason a couple of empty paragraphs which we don't need. So let's use the explain text defined here and set it to true, because both of them are booleans, as we can see in the docs. Now let's get back to our main action query, and you see, so this is like first level, second level, so prop. Now we need to search for a thing called generator, and generator is get the list of pages to work on by executing the specified query module. Note, generator parameter names must be prefixed with a G, so the generator has a thing called search, and we're gonna do perform a full text search. From what I understand, this helps us to take whatever the user puts in the input field and then send it to Wikipedia. This way we tell it, hey, give us everything you have that includes this term. I might be wrong, but this is where I got. Generator search. Save it, and if we click here on the search, we have the search limit or search namespace. So remember, every parameter needs to be prepended with a G. This is what they meant. They meant that this SR limit needs to be GSR limit, and we're gonna set it to 20. That's most of the things that we need for our app to work. So what was the second step? Read through the API's documentation and understand what needs to be included in the params of the request. Create a generic params object, and that's what we did. Why is it saying generic params object? Because in the params object, we will also need to send whatever the user has inputted in the input field, but this cannot be generic because it depends on the input, right, of the user. So we're gonna be extending the params object later on. We're done with step 2. Step 3, register event listeners, fetch the data per the user's input. Let's go back to our API. We have here an input field and we have here a button, which we know because we have already extracted them. Let's register event listeners on those two elements. Const register event handlers, arrow function. We define the element input dot add event listener, open parentheses, and in the first place you define which event you want to listen to. In our case, it's going to be a key down, and then we're going to define a function which we want to call. Let's leave it up like this for now. Then we have our submit button dot add event listener. The event we were going to be listening for is click, and as well here we're going to define a function. Now we could assume that those two elements are going to be calling the exact same function, with one small difference though. The input field on key down is going to fire when a key down on any key. We want to call the function that is later on going to submit our request only when the user presses on enter. So let's first create a handle key event function. We're going to define it here, const handle key event. We're going to be passing to it the E, as we have defined the function here, and it's an event listener. The event is going to be passed to us, and we can very easily check if e.key equals enter, as simple as that. Then we would like to call the next function, and the next function would be exactly the same function as we will be calling here. So let's call it get data, and in our submit button specify it, get data. Let's create the get data. And let's check. So the step number 3 was register event listeners, fetch the data per the user's input. We registered the event listeners. We can check if they work. Let's console log, get data, go to our page, refresh it, open the console, click on the console tab, API. I pressed on enter. That didn't work. Why? Because we never called the register event handlers. We need to call them. Refresh the page, click on enter, get data, press on the button, get data. Cool. Instead of console log, we're gonna start doing this part, fetch the data per the user's input. So in order to fetch the data per the user's input, we need to know what the user's input is. We have extracted our input field right here, and the way we can use it is we write const user input equals input.value, and this is how we're gonna get the user input. Console log it to see that we actually get in it. User input, save it, refresh, do you see me? Enter, yes, do you see me? me. That's exactly our value. And remember, we have this function is input empty. And why not straight away check it here before we continue with anything? If, and you can call functions in the if, is input empty. And that's why it's helpful to call this function is input empty, because you kind of already get the sense that it's going to be or true or false. It works perfectly with our if. We need to pass the value user input, and if it's empty, then we want to return. Let's do a console log here and say not empty and give it a try. Refresh the page, click on submit, doesn't do anything. Press on enter, doesn't do anything. Not empty, enter, not empty. Perfect, so we got that to work. Remove our console log. We said that we want our params to include the user's input. This can happen, let me open where it was, this parameter. Search for page titles or content matching this value. That's us. Params dot, we prepend it with a G because we use the generator, sr search equals user input. To the fun part, we're gonna start sending the data. Before we send the data, we want to use one of our helper functions, which is disable UI. As I always mention, we don't want to submit multiple API requests while we have one request already ongoing. And while this might not block the API request from being submitted, because users still can go in the code and remove the disabled, so usually you would have an extra check here or create a flag if you have already a request going on that you're just gonna return out of this function. But for the sake of just this small app, our disable UI function will suffice. I mentioned that we're gonna be using Axios as a way to communicate with our API, and what's Axios is a promise-based HTTP client. They have a massive documentation. So here is an important part. For convenience, aliases have been provided for all supported request methods. You can write the URL and then the config. And the config, check here request config, we see here params. Params are the URL parameters to be sent with the request. Must be a plain object or a URL search params object. In our case, is a simple object. So let's start constructing it. We know we need to call Axios, which is available in our HTML, and that's why we can use Axios. Axios.get. Then we need to define our URL, as I mentioned here, which is stored in our endpoint variable, endpoint, comma. The square brackets here mean that this thing is optional. For example, the API doesn't require any params and can just give us data like this. You can omit the config. In our case, that's where we're going to pass the params. They mentioned the params are an object and the config itself is an object. You see, it starts with an object, meaning that we're opening an object. Then we're defining params, which are our params. And in ES6, you can shorten that and just have params and save it. The way how we can proceed, we can use .then, but since we have already used .then in our yes/no API challenge, let's use something else. Today we're going to be using async await. What is async await and how do we use it? Async and await are reserved words. Await comes before our request. So we would write await axios.get something something, and we write await because if we want to display results container in our HTML equals to whatever we get from this request. The way JavaScript works is that it's not going to wait for Wikipedia to give us information and then display it, because we never told it to wait. JavaScript doesn't do that by itself. In order to tell it to wait, we're telling it, hey, await this request, and then we can store in our variable const response whatever is returned from this request. But await doesn't come by itself, it comes with an async, and the async you need to define here. But they always come together. JavaScript needs to know in advance that this function is async and there's gonna be await there inside. What we're doing here, we're saying go and find our data that we requested and then give it back to us. JavaScript knows that it needs to wait and not continue doing anything else before they get a response. And the response can be or success or an error, but it knows it needs to wait for it. So let's remove this thing and console log our response. Let's search for Apple. Look, this is our response. We have response, then .data, .query, .pages, and this is everything that we need. You see Apple, macOS, Fiona Apple, etc., etc. And what is gonna happen if we receive an error? For example, if we remove these params, if we comment them, save it, refresh the page, write Apple again, enter, and what do we get? We get data and we get error. Every time we get a response, we get it in response and data. We can deconstruct here this const variable that we have. In order to access straight away the data, we can just write curly brackets, and data. And this will automatically give us the data that is inside of the response. Let me show you. Refresh, Apple. We get now one level deeper. So let's uncomment it back, save it. Apple, query, pages. Cool. Our third step was register event listeners, fetch the data per the user's input. We did it. Step number 4, output results to the UI, success and error. Let's remove this console log. If you're going to be getting a success response or an error response, you would most likely need to have if statements to check if it's true, if it's false. There is one thing that can help us with that, and it's called try catch. Basically a block that you write this way. Try, you put your request inside of the try, then you write catch, expect an error, and then you do something with the error. And in our case, we're going to be doing show error, pass it the error. But it's not really a magic that's just gonna work by itself. Our error lives in data.error. So the catch will not know if the API threw an error, because this error was not network error or something else. This was specifically that we didn't provide a parameter that the API expected. So what we would need to do, we would need to check if the data contains the error, and then we would need to throw an error that is then gonna be caught in the catch block. Let's do that. If data.error throw new error, and we can define here the message error for now. And what this throw new error is going to do, it's going to basically trigger this catch block, which eventually then trigger the show error and then go to our show error and then output it in our UI. We want our error to be a little bit more descriptive, so let's find if Wikipedia gives us an error message. Let's again comment this in order to get to the error point, refresh, Apple, search, error. But in our network, here is our request. We can see the error and the info. So in here, we would write data.error.info, and this is what we want to show to the user in the UI. Save it, refresh, Apple, search, the GSR search parameter must be set. Cool, so we got this error working. Let's uncomment this again. Why to even use the try catch? Let's say again our scenario where we want to show the results. Once we got the data, we want to call results container dot inner HTML equals response or equals data query pages. This is gonna do a similar thing like we would return out of a function, but it's a more elegant way because there is an error. You're triggering the catch block, which has its own functionality, and it's gonna stop from running whatever you have left in the try block. So if you have many more things here that you need to do, it's gonna abort them and it's gonna just go straight away to the catch block. We want to also enable our UI. The thing is, we could write here enable UI. We need also to write here enable UI. No, there is a better way to do that. And this is something that I didn't come across ever in any code I've touched. There is a thing called finally, which is the last block of the try catch. It's gonna be called after the try or the catch. So in any case scenario, it's gonna be called. And this is a perfect place where we can call our enable UI. Let's check it out. This is like so helpful. Apple, search. Do we have any errors? No. Can we search again? Yeah, we can. Let's check our network that it was a successful request. And we have the data, query, pages, and the pages have the Apple. Perfect, that works. That's a pretty cool thing that the try catch offers. And if you get to a point where you're going to be using try catch, then definitely try and use the finally, because I think it's very underrated and extremely helpful. Okay, now that we have the try catch finally, let's continue with our try block and actually output the data to the user. And in order to output the data to the user, if you have done, which challenge was that? The lyrics and the weather API challenges, then you would know about the system that I first like to create a function where we gather the data, prepare it, and then have another function that is actually templating the data to the UI. So first, let's see what the template is going to be expecting to receive. After that, we will be able to build the gathering of the data. Const show results, that's the one that is going to be already outputting the data. I'm going to copy it and paste it. And as in previous challenges, let me close this bar. Feel free to stop and to code it yourself, or go to the finished result folder on GitHub and copy that from there. We see here that it's going to be expecting the results, and the results are these ones that we see here in pages. This is everything that we want to output to the user. We have the results container somewhere here. It's empty right now. So it's going to take whatever it has and add additionally to it this bunch for every result. And we know that it's going to be expecting the page ID that is going to link later on to the Wikipedia page. We will need the title and we will need the intro. We can now create const gather data arrow function. And in the gather data, we're going to expect in the pages. Pass here pages. If you notice, the results have a for each. For each works on arrays, but the response that we're getting is an object. So what we will need to do in gather data is to transform our object to an array and maybe change some stuff. So the way we're gonna transform our object to an array is by using such a thing called object.values, and we're gonna pass them the pages. Object.values returns an array where each item of the array is the value of the respective object. You know what I mean? Now we have an object of pages that has a key 856, and then the value of it is an object of itself. What we're going to receive in the array is only the value, the key was removed, and the data form is an array. We can always console log it, and before we will be able to see the console log, we need to call the gather data. After we figure that we don't have an error, gonna call gather data. We expect the pages, and the pages are in data, right? The whole response is data, query, pages, and that's what we're gonna do. Data, query, pages. Let's see if that works. Apple, search, go to console. There we go. You see, this is an array, and you see this is index of the array. It's not the key of it. We have now all the information that we need, but in the form of the array. We have extract, index, NS, page ID, and title. We said that we only need title, page ID, and this information, extract. And the way we can do that, remove the console log. Since we know that object.values returns us an array, we can chain a dot map on top of it. We're gonna access the page, and we would want to return an object with only the values that we need. For example, page ID is going to be page.pageID. Then we have our title, page.title. Intro, page.extract. We could have also just spread the information that we need here, but what if you would want to have maybe a shorter intro or a longer intro if Wikipedia API would not offer us the amount of characters that we want to retrieve? This would be your function where you're transforming your data to something that you want. As we know, map returns us a new array. We need to store it somewhere. Const results equals, and we're going to be calling show results with our results array. Save it, search for our apple, and there we go. Cool, isn't it? And if we click on it, this is going to redirect us. Yes. Awesome. Let's check our steps. Output results to the UI, success and error. We did that. Adjust UI states accordingly. There is one more thing that we didn't do. If I'm going to search now for pair, enter, then what's gonna happen? Just gonna append all the results to what we already got. And that's not what we want probably, right? Because when you search for something, you want only those results to be shown. We missed using clear previous results before disabling our UI, I would say. So before our new request goes through, clear the previous results, disable the UI, try and make our requests, and then continue with the rest. Let's search maybe for API this time. Enter, we got our information, front end and back end. Let's check, yep, works. Let's search for, I don't know, olives. Yes, we got it to work. Nice. And that was it. Honestly, the hardest part here was figuring out the API and how it works. As you saw, there are so many options, so I really encourage you to go and try out if you want to try something else, if you want to extend the app, or if you want to play around with different parameters. And while this was a quite simple thing, we did cover a lot. We covered Axios, we covered params, we covered how to attach things to objects that already exist, async await, try catch. Finally, let me know if you have ever heard of finally, because seriously, I have never heard of it before and never seen it in use. Maybe there's a reason for that, I'm not sure. Maybe it's just extremely underrated, which is a shame. I hope you enjoyed this challenge, and I'm looking forward to seeing you in the next one. Bye!